Hey guys, welcome back to All Things Electromechanical. In this episode we're going to be checking out a shop-vac. My wife says it doesn't work no more, so we're going to go ahead and figure out why it's not working. Stay tuned. Okay, so the first thing we're going to do is plug it into a known power source and double check to make sure it's not working. Hit the switch, nothing's coming on, nothing. Okay, so let's get out the multimeter. Okay, I have the leads on the hot and common side of the plug, and we have nothing. I'm gonna tap this switch to turn it on, and we're getting no change in state. How about a change to ground? No shorts to ground from there to there, and no shorts to ground from there to there, and the machine is turned on. Okay, so it looks like we're gonna have to open this guy up. Okay, so the first thing you're gonna do is separate the top from the bottom basket. You can set that aside, and then there's 8 bolts. You're gonna use a T25 Torx bit, and I've got one I put on my drill, and there's 8 bolts that you're gonna remove around the inside. If you flip this thing, the top of the motor upside down, there's 8 bolts. 1 there, 2 there, 2 there, 2 over here, and then 2 on this side as well. And you're gonna go ahead and remove those. And like I said, they're 8 Torx bits. Screws. Okay, I'm just gonna remove this cover from the 8 screws. You can set that in the bucket and move that to the side. Okay, and once the cover's removed, you can just pick up the whole motor and separate it from the top cover of the shop-vac and set that aside. And so now we're going to be working on this unit. You can see it's really dusty. We're going to go ahead and clean that up and find out why this guy is not turning on. Okay, and in order to remove this top from here, there's a screw, another T25 here, and over here. You'll have to remove those screws to take this cover off, and then you just slide the top off and move that off to the side so we can gain access to the motor. Alright, so I just blew it out with my little Ryobi blower here, and you can see I'm just checking out this the pump fan for the blade for the pump, the vacuum pump, and you can kind of just pulling out some debris that have gotten stuck in here. And you want to go ahead and just inspect all of these internal fan blades and make sure those are cleared out and cleaned. Looks like some kind of hair or something got in there. Okay, so to remove the plastic top from the cover, we're going to rotate this to the upside down, and there's some more screws. You can see them down there. There's 1, 2, 3 more screws, and then we should be able to separate this top, these 2 pieces here from the motor and the electrical. Look, and I just added my Torx bit with an extension to get these 3 bolts out. Okay, so once you remove those 3 screws from the bottom, this top should be able to wiggle off and separate from the motor. Okay, and once it's separated closely, we're going to go ahead and check for continuity within the circuit. Here's your power service coming in, and you can see it. It's the black and white and green, and that's going into this rocker switch in, and then on the other side of that switch, the toggle switch is coming over to, you have 2 reds, and those are plugging into these 2 terminals down here. So the next thing I'm going to do is I'm going to remove the input leads from the 120 volt source and the output leads that go to the motor and the switch. All it does is jump power from these 2 leads over to these 2 leads and then to the motor. Very simple. So I'm going to disconnect these leads and these leads from the switch, and we're going to check for continuity on both sides across the switch. Okay, so here I have the switch, and here's a close-up of the 4 terminals. And what we're gonna do is take our 2 leads that we've separated and put one on each side and test across these 2 with our meter for continuity while switching the switch. Okay, so we have our 2 wires across the terminals and they're plugged into my meter, and when I switch this switch we should have a complete loop and we should hear an audible. Okay, so that means that one side of the switch is good. Okay, so here's the other side, and we're gonna switch it. Okay, so we have an audible. That means we have continuity across both sides of the switch, and our wires are good as well. Okay, and to test the power source, we have 1 lead on one side of the plug, and we're gonna check, and we have an audible there, and none on the other side. And now we have the lead on the other side, and we're gonna check over here for continuity, and we have an audible. So that's basically saying our power source cable is good, the cabling from the output of the switch is good, so into the switch, out of the switch, and the switch itself is good. So the next thing we're going to do is ohm the motor. Okay, so now we have the test leads over into the motor, and we're going to sound for an audible. Nothing. Touch this side. Continuity but nothing on this side. So we're going to have to look further into the circuitry in this area. Okay, so we have 2 T10 bolts right here on both sides of the bearing support for the motor. We're going to go ahead and remove those 2. Okay, and once those 2 bolts are undone, you should be able to slide this up. Take note, one bolt, the left bolt, is longer than the other bolt. The shorter bolt, it looks to have the ground cable. We'll set that off to the side, and then we'll go ahead and check this guy out here. Okay, so to disassemble the pump off of the rotor for the motor, you're going to remove this tab, and that will just pull up with a screwdriver. You can just pry underneath it and pop it off. I'm going to spray some lube here, and you can see this thing will start to press off of the shaft. It looks like it's been pressed on, so you just wiggle it off. It should come off. And I just took mine off. We're going to go ahead and spray a little bit of this PE. Just a little bit of that penetrating oil, just to loosen things up on the shaft. And we're going to go ahead and just kind of back and forth work its way up off of the rotor shaft there. Just like this. Just like that. And it just wiggles right off of the shaft. So once the pump fan has been removed, looks like they've changed the hardware on us to Phillips. So we're going to go ahead and take these Phillips screws off of the this motor frame, and the motor should actually fall down and separate from the plastic housing that this motor is actually bolted to. Okay, and then it has settled down. Move the plastic off to the side. Now we've gained access to the motor. Looks like some debris has gotten into the bearings. Go ahead and remove this, because mechanically can cause these to fail. And this stuff right here, whatever it is, hair, I don't know, it just got into these bearings, and it just sucks into those bearings and causes them to fail prematurely, and it just destroys bearings. You would think the screens and all the filtration system, you would think that it would keep all that from happening, but somehow they find their way in there. So it looks like from our 2 wires here coming in, and it looks like they've been neatly separated, but they're coming in, and then you have your induction coils. This could be bad. We'll go ahead and ohm that up right now. This is a brush style motor, and you can see down here there's a cable that loops around, and there's a brush that slips through here on both sides, and they slip on this rotor here, right down in here. You can see the brush down in there, and those actually look to be really good, and very minimal wear on those. You can see, I'll just move this over. You can see the spring that's moving, and both of these brushes here, one on the left and the right, they are slipping on this rotor here. Sorry guys about the lighting, but they're slipping on this rotor. You can see the track marks, and those actually look pretty good. So we're gonna pass those in the circuit, and we're gonna head on over back to this guy, which I'm suspecting the thermal overload has failed, and it's like basically a fuse, and this has failed in the circuit, and we're gonna go ahead and test that now. Okay, I've got my meter set, and both of the leads are across this component, and I'm not getting anything. Touch this side, that lets us know we have a good connection, and then this side we're getting nothing. So here is the part that's failed. We're gonna remove this from the housing that it's been retained, and dissect this part. Okay, so I've taken this thing off the plastic housing, and I'm just kind of inspecting it. You can see down in there, whatever it is has burned up, it overloaded, and it shorted out this component. So this component is completely failed. Now for testing purposes, I'm going to go ahead and short these terminals across, and we're going to go ahead and just see if this motor kicks over. And if it does, we're going to either order this part or replace. If we can't locate this part, we're going to use a different part that does the same exact job. Okay guys, so what I'm going to do is I'm going to bend these two tabs over. Then I'm going to take this 30 amp car fuse, and I'm going to plug it in here just like this, in the back behind these terminals. And it's going to plug in right there. Okay, now I'm going to force it down in there pretty tight as I can get it. Bend these back, and what this should do is basically jump this wire over to this wire, completing the circuit, turning on this motor. Now I'm going to assemble this all back up and run it and see if it'll start up for you guys. I'm going to clean this up, maybe drop some 3-in-1 oil and bolt the bearings, get those freed up, and then I'm going to solder this lead back on so it's a little bit tight, it's not loose, and then we're going to see if this thing starts back up. Just going to go ahead and plug this into a known source and see if it fires up. Alright, looks like we got a rhythm. Cool. We're gonna go ahead and put this thing back together and give it a test run. Okay guys, I got the unit all put back together, got some sawdust. We're gonna go ahead and test this guy out. I'm gonna go ahead and turn him on. Alright, I'd say she's working good as new. And can't really put a guarantee on how long it's gonna last, but my wife for sure, she's gonna be happy. It's working again. She can continue to make a mess and with her business, and now she has her vacuum back up and running. So hey, if you like this video and it helps you out fix your shop vac, and which I hope it does, check out some of my other videos and subscribe. Hey, thanks for watching.